If y is a function of x made up of a sum of terms like this, where the exponent b is a positive integer or 0, then the derivative of y with respect to x is given by this rule here. And it turns out that if b is a negative integer or a rational number, then y is no longer a polynomial. But this same rule still applies for taking its derivative. And I'll leave it to your calculus teacher to prove that that's true. But even more generally, if b, the exponent, is an irrational number, like pi or the square root of 2, then y is definitely not a polynomial, but the same derivative rule still holds. So in fact, the coefficient a and the exponent b can be any real numbers, and this is exactly how you find the derivative of such a function. So let's try it out. In this example, we've got a position function as the sum of these 5 terms, and you can apply this rule to find the corresponding velocity function. So go ahead and pause the video now and try that out. Work out the first derivative of this position function to find the corresponding velocity function. Ready? Okay. First off, did you state your equation? The velocity function is dx dt. State that derivative relationship before you put down your answer. Okay, maybe you got tripped up by the square root term here and the 1 over t term here. So let me note that the square root of t is equivalent to t to the 1/2. So that's how you can get this term into a form that matches this up here. That's t to the 1/2. And a over t is equal to a times t to the -1. So you can get that term into this form. So b is 1/2 in this term, and b is -1 on that term there. Okay, so if that tripped you up, then try it again. Pause the video, fix your derivative. Okay, ready? Here's the actual answer. We have here the t to the 3.6 became 3.6 times t to the 2.6. We just took this value and subtracted 1 to get the new exponent. 3t to the 1/2. 1/2 times 3 gave us 1.5, and 1/2 minus 1 is -1/2 right there. Likewise here, -3 times the -2.5 got us this, and -3 minus 1 gave us -4. Here, where the exponent was irrational, pi times the old coefficient gives us the new coefficient, and we just take pi minus 1 is the new exponent. And likewise here, t to the -1 minus 1 times a is minus a, and then the -1 minus 1 becomes t to the -2. All right, try it again now. Find the second derivative of the position function, or the first derivative of the velocity function. Those will give you the acceleration function. Pause the video now and try that again. Ready? Okay. First of all, did you state your equation? A of t is equal to dv dt, or equivalently, the second derivative of x with respect to time, d squared x dt squared. State that equation. Apply the rule. Check your work. Here's the result.